Thank you so much for your patience, everybody. Welcome for the Fleet Science Center Sharp Minds lecture series. Welcome to everyone who's been with us before, either at the Fleet Science Center when we do these once a month on a Monday morning, or last week when we had our first online Sharp Minds. If you haven't been with us before, Sharp Minds is a monthly lecture series at the Fleet Science Center. We normally, during normal times, host these on the Monday morning at the Fleet Science Center. But with the circumstances we have right now, we're quite happy to at least offer them online for you, so you can still get your science fix, you can still continue your learning and still engage in science. I'm very excited for tonight's talk. We have with us Gideon Marcus. He's a space historian, and he's here to tell us all about the women pioneers in space science. So Gideon, if you want to take it away, it's all yours.
Thank you very much. This is actually my second talk at the Fleet. Last year, some of you may remember that I did a talk on the Mercury and Vostok programs, our first steps into space on both sides of the pole. And this time, I'm going to talk about some of the unsung women pioneers of space science. Some of you out there may have seen the movie Hidden Figures that came out a few years ago, and that really shone a light on some of these people that had not necessarily been in the forefront of history. And I can promise you that the three women who were showcased in that movie will be talked about tonight, along with many, many others. So if you'll bear with me, I'm going to share my screen. It worked. Now I need to figure out how to go to the next slide. So I'm going to start with a conversation on computers, because computers were in many ways the gateway for women to enter the space program in a big way, long before they were allowed to be astronauts or be on the International Space Station and whatnot. There were dozens, hundreds of women involved in computing. So let's talk about how that happened. When you think about computing, you think about digital computers. You think about what you're using to watch this show right now. But in fact, 100 years ago, the word computer had a much different meaning, which I'll let you know what that is. Oh, I know what to do. Ta-da! 100 years ago, this was a computer. You can see this, right? Very good. So these are the computers working for the astronomer Henry Pickering at Harvard. And their job was to do mathematical computations. They spent all day figuring out how stars moved, the light curve of what we were seeing through telescopes, the orbital calculations. These were invaluable contributors to astronomical science in a time when we didn't have desktop or even room-filled computers. Instead, smart people did it themselves, and they were mostly women. And the head of this particular team was a woman named Henrietta Swan Leavitt, no relation to Henry Pickering. Henrietta Swan Leavitt is especially important because what Henry Pickering specialized in was in spectroscopic binaries. And what that means is you often find two stars in close orbit around each other. You can't tell that they're two stars until you look at them through a telescope, and even then you might not be able to tell. But if you break up their light into a spectrum, you can see that it's blue shifting or red shifting. You can see that there are two components. You can also see them dimming or brightening as the brighter or dimmer component gets in front of the other. And so what Henry Pickering did was he gave Henrietta Swan Leavitt all the data that he had for spectroscopic binaries. And she discovered something very interesting. So she studied a particular kind of star called a Cepheid variable. And a Cepheid variable was a class of star that would occasionally get bright and then pulse down, and then get bright and pulse down. And what she discovered was there was an absolute relationship between how bright the star was and how fast it pulsed. And once she figured that out, she was able to develop the first cosmic yardstick, because if you know how bright something is supposed to be, and you know how bright it actually is when you see it, you know how far away it is. And because of Henrietta Swan Leavitt, we were no longer limited to finding stars within a few light years. We could find stars hundreds and thousands of light years away. And it's no coincidence that this still very important law is known as Leavitt's law. So now we're going to fast forward to, we're still talking about manual computers. These folks. When NACA, the National Advisory Council on Aeronautics, came into existence, they were working out calculations for aircraft. And they were a fairly small organization. They were engaged in research, figuring out how wings worked and engines worked and planes worked, and contributing their knowledge to the military and aviation services. And then Sputnik was launched, and all of a sudden NACA was tasked with space shots, something they weren't terribly well equipped for. And so NACA ultimately became NASA. But before they were NASA, they were NACA, and they were contributing to endeavors like World War II. And NACA actually had several installations of computers. These were one batch of computers. But if you happened not to be white, you went to a separate batch of computers if you were working at the Langley Research Center. And the reason why is the Langley Research Center was located in the South. And in the South, Black people were segregated from white people. And so this is Dorothy Vaughan. She's the first person you will recognize from Hidden Figures. She worked at the segregated West Area Computing Unit at the Langley Research Center. She joined in 1943, right in the thick of World War II. She very quickly advanced to the rank of manager, and she was the first Black manager at NACA. Now, what's interesting about Dorothy, she worked there for a very long time, all the way through when NACA became NASA. And she saw the writing on the wall. In the late 50s, digital computers had become fairly ubiquitous. There were thousands of them, in fact, and many of them were made by the premier computer of the age, International Business Machines, or IBM. And she saw that at some point, NASA was going to bring in these computers because they could do work faster than any human could. And so she knew if she wanted to be on the cutting edge of technology, if she wanted to ultimately keep her job if the human computers were phased out, she had to learn how to program these computers. So she taught herself the language that was de rigueur at the time, a language called Fortran, which means Formula Translator. And it was one of the first languages that actually was something akin to English, where you could talk to a computer as opposed to just using ones and zeros or letters. So not only did she learn this, but she taught it to the dozens of people working for her. And as a result, her department was able to transition to being programmers for the first computers at NASA. So what you saw in the movie, to some degree, was accurate. And what's interesting is programming, for the most part, was considered women's work by the engineers at NASA. And therefore, there was not a lot of competition when they applied for those programmer positions at NASA. And that's why in early NASA, there were so many women programmers. It's really interesting. So Dorothy Vaughan stayed with NASA all the way until 1971. After NASA was formed, she worked on the Scout rocket booster, which was a solid fuel booster, very cheap civilian booster that launched a great many satellites. So she contributed a great deal to our early space efforts. One of her proteges at the West Area Computing Unit at Langley was Katherine Johnson, who passed away recently. She was pretty much the protagonist, probably the star of Hidden Figures, and very famous. She joined the West Area Computing Unit in 1953, and she continued until NASA was formed and went to work on Mercury. She was the first woman at what became called the Flight Research Division at NASA, and its title was the catchy Determination of Azimuth Angle at Burnout for Placing a Satellite Over a Selected Earth Position. Now that's a sexy title, but what it really is how to compute the trajectory of something you are sending into orbit, which is a very important thing to know if you're sending, say, a person in a tin can at the top of a firecracker. So she actually did the trajectory analysis for the first suborbital flight done by Alan Shepard. So her handwriting was imprinted into the early space program from the very beginning. She had such a strong reputation for accuracy that when Glenn went up to his gantry, he asked if she had done the calculations, and they said she had, and they were right. And he said, that's good enough for me. That scene you saw in the movie, although the timing was not strictly accurate, did in fact happen. So well respected was Katherine Johnson. Katherine Johnson went on to work on several crewed space programs, including Project Apollo's lunar lander, which would dock with the command and service module in orbit. She also worked on the space shuttle. In robotic programs, she worked on the Earth Resources satellite. She ultimately authored or co-authored 26 research reports. So that's Katherine Johnson. Mary Jackson was the third person who was covered in Hidden Figures. And although Mary Jackson was not strictly a space scientist, nevertheless, her work was crucial to aeronautics and ultimately had a lot of application to space, because what she did was she worked in wind tunnels. And what a wind tunnel does is it's this hurricane force metal tube where you put in some sort of object to see how its shape will interact with high speeds. Now, she didn't start out as a wind tunnel engineer. In fact, she wasn't an engineer at all. She was a teacher with a dual degree in math and physical sciences. She ended up under Dorothy Vaughan at the West Area Computing Center in 1951. But 2 years later, she was invited to work at the 60,000 horsepower supersonic pressure tunnel by Kazimierz Zarnecki. She took the job. She did a great job there, and you saw this in the movie. And Zarnecki wanted her to take graduate level math and physics courses so she could get an advanced degree and continue moving up. The problem was the only night classes were at the segregated Hampton High School. So she, just like in the movie, had to solicit permission from a judge to become a student at this school to finish her degree, which just tells you some of the obstacles people had to surmount just to get as educated as everybody else. But she did succeed, and in 1958, she became NASA's first Black female engineer. And the same year, she co-authored her first report, Effects of Nose Angle and Mach Number on Transition on Cones at Supersonic Speeds. So she worked at NASA for 2 decades, basically going as high as she could, and she eventually took a demotion so she could be head of the Equal Opportunity Department, because she saw that it wasn't just her who needed to advance, it was all of her colleagues. So she stepped down a grade so that she could assist everyone else in getting their leg up. So she ended up filling the position of Langley's Federal Women's Program Manager. She retired from Langley in 1985. Now, this is all things that happened on the East Coast. Now I'm going to take you to the West Coast, again, before NASA. So in the Los Angeles area, there was a place, and there still is, called Jet Propulsion Laboratory in Pasadena, associated with Caltech. And Jet Propulsion Laboratory, as you might guess, was engaged in the investigation and research of the cutting-edge jet engines of the late 40s, early 50s. And they also needed computers for their calculations. Now, we are currently looking at Sue Finley. Now, Sue Finley wanted to be an architect, and she went to Claremont College in San Diego County and took 3 years of art, and then discovered they wouldn't transfer. So she had to get a job, and she went to a place that hired secretaries, and they turns out they were looking for computers, and they said, "How do you feel about math?" And she said, "I like math a lot more than typing." So she got a job as a computer working for this company in San Diego. She was using these calculators that you saw in Hidden Figures called Frieden calculators. They were these big mechanical calculators. And she and another woman punched the numbers for about 40 engineers. So she did that for a few months. Then she got married and moved away with her husband, who had just graduated from Caltech. And because he graduated from Caltech, she got the word that maybe she should apply to be a computer at JPL, which she did. And she applied to the lab in 1958, just a few days after America's first satellite went into orbit, Explorer 1. So she worked there for 3 years. And then she took time off because her husband wanted to get her advanced degree. And of course, in the early 1960s, a woman stayed home and took care of the house while her husband got educated. That said, during this hiatus, like Dorothy Vaughan, she learned how to program. And in a few years after her husband had gotten her degree, she went back to JPL as a computer programmer. Now, what's really interesting about Sue Finley is she was still sometimes tasked to do things by hand, because during a live space flight, for instance, a computer might be very good at crunching all the calculations before a spaceship took off, but once it was in space, the computer couldn't keep up. And so Sue Finley was actually tasked to keep track of where a spaceship was. So for instance, the third Ranger flight, Ranger was a project that went to the moon, missed the moon. And they didn't know by how much. So she got out her pen and paper and Freedom calculator and calculated that Ranger 3, in fact, was going to miss the moon by about 20,000 miles. She went on to work through the 80s as an engineer, as a programmer, working on the Deep Space Network, which is the communications grid that connects the Earth to the stars. Without the DSN, you couldn't do any science because you couldn't listen to what the long-range satellites were telling you. So Sue Finley contributed to space almost in this weird Brownian motion course through life. Again, she went through the computing, as so many women did. Now I'm going to leave computers and go to women pioneers who majored, who went in specifically and got a degree and entered NASA as scientists and engineers. The woman on the left is Marcia Neugebauer, who had a master's in physics. She was from New York, and she majored in physics at a time when girls didn't major in physics. In fact, she was the only one in her class, which suited her just fine because, as she put it, if there were two women in the class, men wouldn't talk to you. They'd figured you'd just talk to each other. But because it was just her, she would actually get to associate with men on mostly even terms. So as a physicist, her particular interest was in solar radiation. How does the sun, while it's fusing its hydrogen, turning into energy, casting off a rain of electrons and other charged particles and electromagnetic waves through the solar system, how did that process work? How could they be mapped? So she went to JPL and she worked on a probe called Mariner 2, which interestingly enough was based on the Ranger chassis. And she was the head scientist for the space plasma experiment on Mariner 2. So she was responsible for one of the first probes that went near the sun, because it was a Venus probe. So it went closer to the sun than any other probe had gone before, measured the sun's output the whole time. She was in charge of that. And she continued to work on several space probes after that as an important space engineer. Now, the woman on the right, originally when I put this presentation together, I've done this a few times, I was not going to talk about her, but I saw her and I said, well, I have to know who this is. I have to talk about her if she's going to be in this picture. There's not too much known about her. She is Phyllis Buwalda, and she was also a computer at JPL and obviously worked with Marcia Neugebauer, at least for that picture. She was involved with Project Ranger. Later, she directed future mission studies at JPL. But I think my favorite story about Phyllis Buwalda is she was working on the Surveyor project. So Ranger's job was to crash into the moon. Seriously, its job was to hit the moon. But while it was going towards the moon, it took pictures. And for about 15 minutes, it took ever increasing resolution pictures of the moon until it crashed. Surveyor's job was to land on the moon. And in fact, Surveyor had this tiny little buggy that it would deploy that could go out a few feet and measure the lunar surface away from the main chassis of the probe. Now, what was interesting was in 1965, no one knew what the surface of the moon was like. No one had stepped on it. And it was actually really important to know what it was like because they were worried that an astronaut might jump off the lunar module and then sink into 10 feet of dust. They were worried that would happen to their buggy too. So they had 4 different options as to what the tires would be like on this buggy for all different conditions. And the program was stopped because no one could decide through this dilemma. And finally, Phyllis Buwalda said, you know what? Look, we should just pick the most complicated surface I can think of and aim for that. And in fact, the surface is not very much different from the caked desert that you see right outside JPL. So why don't we just plan for that and go forward? And they did, and it worked. So thank you, Phyllis Buwalda. All right, now we're going to go to one of my very favorite ones, and one almost nobody knows about unless you've been to my shows. So this is Lauren van der Waal, but everyone called her Frankie. She was a 6-foot titan of a woman. She ultimately had a master's degree in aeronautics, but she didn't start there. She graduated at age 15. She was a showgirl, an airplane mechanic, a deputy sheriff, and before she got her degree in aeronautics. And she went to work for what was essentially the competitor to JPL. So JPL did a lot of its work for the Army and ultimately civilian programs in NASA. STL, Space Technology Laboratories in Redondo Beach at the other end of the San Gabriel Valley, worked for the Air Force. And Frankie van der Waal was a biomedicist. That means she was responsible for understanding the effects of aeronautics and space travel on living things. Now, right after Sputnik went up, the smart people at STL said, hey, we've got to beat the Russians to the moon. Why don't we take off-the-shelf rockets that we currently have and we'll build something that'll work to go to the moon. We can also use this to test our ICBM warheads. They can go up, they can come back down, and they'll be at re-entry speeds, and we can see how the atmospheric friction works and make sure the warheads stick together so your bomb doesn't blow up 200 miles in the air, which doesn't do anybody any good. So this project was called Thor Able, and it combined the Thor intermediate range missile with the Vanguard second and third stage. The Vanguard was the rocket that was supposed to launch the first American satellite into space, but blew up before it could, but ultimately launched 3 Vanguards into orbit, Vanguards 1, 2, and 3. So this Thor Able program was a suite of missiles that would test these warheads. Now, these warheads were dummies, right? They were just the cones, and they were empty. And Frankie van der Waal said, why don't we put experiments in there since we're launching these up anyway? And she had these rats, or mice actually. She had these mice that were strapped into these little couches with little heart monitors plugged into them and other things to measure their temperature and such. Poor little mice. Not really poor little mice. The person who worked across from her, Chuck Sonnet, talked about how at one point Frankie van der Waal said, hey, Chuck, come here, hold down the mouse so I can strap it in. And it peed on her. So he wasn't terribly happy about that. Anyway, she was the only woman, as far as I know, the only scientist working at STL. There were other women, but she was the only one at the scientist level. And she was tough as nails. All the men were scared of her, and I suspect she had to do that because of the situation she was in. So this mouse in Able, called Mia for mouse in Able, flew 3 times. Unfortunately, they never recovered any of the mice, so they all were lost at sea. However, they did get great data from them and actually determined that the mouse's heartbeat acted like an accelerometer. You could tell how fast the rocket was going by how fast the mouse heartbeat was going. So she worked for STL for a few more years. Then she got married and left, got involved in local politics. But Frankie van der Waal is just one of my favorites because she had such a versatile background, because she took no grief from anyone and was responsible for the very first American animal program in space. Now, this is one I learned about fairly recently. When I first did this show a couple of years ago, I didn't know about Marjorie Townsend. And those of you who know who I am a time travel. I normally live about 55 years ago through my Galactic Journey site online. And when I got to 1964, I saw this great NASA program called Woman in Charge. And it was about this woman, Marjorie Townsend. And she was the first woman to run a team at NASA. This is the Tyros, which was a weather satellite program. So she enrolled in college at age 15, and she was the first woman to be graduated from the George Washington University School of Engineering in 1951. And when she went to college, everyone assumed that she had just enrolled in college to catch a husband. And in fact, someone made a bet that that was why she was there. And of course, ultimately, he had to pay up because she went to college to learn how to do things like make satellites work. She was, in fact, one of the first female engineers to join NASA. She joined the Goddard Space Flight Center, which still exists in Maryland. And she was responsible for the ground processing equipment. Satellite really has two parts. You have your part in orbit, you have the part that receives and crunches the data. So she was responsible for the processing equipment for its medium resolution infrared camera. Then she went on to work on Nimbus, which was the second generation weather satellite, and the orbiting geophysical observatory. And beyond that, she became head of the team that developed Uhuru, which was the X-ray satellite launched in the late 60s. So Marjorie Townsend started at age 15 and went on to become one of NASA's most important engineers and one of the very first women engineers at NASA. Ascending up the ladder, we're going to end with Dr. Nancy Grace Roman. And the reason why is, of all the people we've seen, all of them were important and contributed a great deal. But Dr. Nancy Grace Roman had the highest title, at least when NASA was formed. So Dr. Nancy Grace Roman was born in Tennessee. And she decided in college to take her second year of math instead of her fifth year of Latin, despite the fact that the teachers looked at her askance and said, "Why would any woman want to take mathematics instead of Latin?" But she took it anyway, and she ultimately got a degree in astronomy, and then an advanced degree in astronomy, and went to work at what was, at the time in the 40s, the hub of astronomical research, Yerkes, at Chicago. Now, at the time, 20% of the women who worked at Yerkes, 20% of the people who worked at Yerkes were women, but they were paid about 2/3 as much. So she went to the department chair, who is Subramanian Chandrasekhar, who is a name you probably know because he's closely associated with black holes and other important astronomical phenomena. And she thought, well, here's a man, he's not a Native American, he's not white, he's going to understand my plight. So she said, why is it that we women astronomers are paid less than male astronomers? And Chandrasekhar said, because you let us. Well, she wouldn't. So she left. And she went to work at the Naval Research Lab in 1955. And when she was there, she was completely snubbed. She was given no assignments, and people treated her like she had the plague. And finally, one of the men there took pity on her and explained to her, well, we had a woman before, and she didn't work out. So we figured women don't work out. Well, eventually, her competence shone through and on the task that she did get, and she became an important person and showed them up for being chauvinist against an entire gender for one person's failings. Nevertheless, she ultimately left because in 1959 she was tapped to lead the space astronomy department at the newly formed NASA. Now, her expertise was astronomy, and so her job was to develop the first orbital observatories. Let me tell you how important this is. When you look out in the night sky, let's say you go out to Death Valley, the clearest skies you can get, and you look up the sky and you see thousands and thousands of stars, and you think, this is it, I am seeing. But you're not, because one, there's an atmosphere in the way, and that causes the jiggling that makes stars twinkle. It's very pretty, but it's bad for astronomical research. But more than that, while it is true that the night sky is transparent to the human eye, it's only transparent in the visible spectrum and in a couple of other wavelengths. For the most part, if you look at the sky with an X-ray detector or infrared, you get nothing. It bounces back. It's opaque. You need to go into space to be able to see most of the universe. Several frequencies of radio are not hearable from the sound. They get blocked by the ionosphere. So what you're looking at here is Dr. Nancy Grace Roman with the Space project that she headed, the very first observatory class program. Until 1962, all of NASA's satellites have been little tiny explorers, which, were useful, important, and the Explorer program has continued to this day. But an observatory class satellite was the first one to have many, many instruments. This one had 12. And the orbiting solar observatory, which was the first in the series, was designed to give long-term measurement of the sun in a wide variety of frequencies over time. So you can see the sun through its cycles. The sun rotates once a month. It goes through an 11-year cycle. You need to have long-term observatories looking at the sun. And she was the head of this program, the first one to do it. Later, she, of course, was involved in the orbiting astronomical observatory, which was a visible light telescope, a really big, which was a precursor of the Hubble, which in fact, she organized the committee of astronomers that designed the Hubble. She was a strong advocate for it. And in fact, when she retired, she had the title, the mother of Hubble. She also passed away quite recently, December 2018, at the age of 93. Now, you may be asking why I'm focusing on women in this talk today. Why did I bring this up? Why am I talking about these people now? I'm not just here tonight to celebrate these women or to celebrate women in general and to show that they had to overcome just to perform along with all the other men who didn't have these obstacles in front of them. It's not just that. These women, every single one of them, had some sort of major accomplishment in their career that altered the course of space exploration. And there is no reason to assume that these advancements would have happened as quickly or even at all without them. And what this demonstrates is the wider your pool of talent, the better chance that you will make progress in any field. Once women were allowed to join the ranks of men, they contributed in ways that the men might never have. Once Black people were allowed to join, there were contributions made that might not have been made. We might not have had, so you may agree with him or you may not agree with him, but President Obama accomplished a great deal, which would have been impossible had the presidency been blocked to Black men, for instance. So I bring this up to show you the importance of reducing as many barriers as possible, to soliciting as many viewpoints, to having as diverse a pool as possible, to make sure that everyone has an equal opportunity to participate in science and engineering and ultimately all walks of life, because that will accelerate progress, which benefits all of us. Now, I don't know if Andrea told you, but I'm here for the next 20 minutes to answer any questions you have about these women, other women, or space science in general, or even what it was like to live back in 1965. So I understand we have a little thing here that allows us to answer questions, and I see that there are a couple here already. Oh, I don't see them yet. So, but there's a lot of you out there, so don't be shy. What would you like to know about what it was like to work in the space program back then? Don't be shy. I'm just going to stare at the camera for the next 20 minutes.
I'm going to start us off with a quick question, so everybody has some time to type something in, because I know it always takes a little while. You have so many little nuggets, stories that you wouldn't necessarily find in newspaper articles or things. How do you get your knowledge about space science and specifically the women in space science?
I do a lot of research. There's plenty of stuff online. There's a lot of, I'm subscribed to Aviation Week and Space, Aviation Weekly and Space Report. I've discovered a lot of interesting things. So The Hidden Figures, for instance, was a really interesting movie, and I'm glad it was made. But it was a very sort of Hollywood presentation, and it got some things wrong that I was surprised at. So for instance, they compressed the time scale. So they showed them all working at NASA, and yet it was segregated. And I found this very interesting because NASA actually was not segregated. When it was founded in 1958, it was not a segregated institution. NACA was, but NASA was not. So while the degradations that we saw the women subjected to in the movie did exist, they didn't by the time frame of the movie, which all takes place after NASA is formed. Another interesting thing was they made a big deal about how Katherine Johnson had to run to go to the colored bathrooms all the way across the campus. Then she came back and ultimately broke down. And because of that, Kevin Costner went out and made sure that there weren't any more colored bathrooms or white bathrooms. It was just bathrooms for everyone. That bothered me because what actually happened was Katherine Johnson was told, oh, those are the colored bathrooms. And she said, yeah, but you know what? I'm going to go to the white bathrooms that are right there. She didn't need the white guy to do it for her. She did it for herself. And I think that's a better story. They gave Mary Jackson some of that spunk, but I wish they'd also given it to Katherine Johnson because she deserved it. But I read a lot. As you can see, I have a tremendous collection of space history books. And all that stuff is out there. You just have to dig into it. And a lot of it doesn't make it into the pop history stuff because it's stuff, there's so much out there, it tends to be rather surface level.
Thank you so much for that. And we do have a question.
Okay.
Starts off with a nice comment saying that your presentation is simply brilliant. What were these women paid? Just to get a sense of the bias there might have been in gender pay as another challenge to equal opportunity employment. So
there's really two elements to this, and I can't give you an exact number for everybody because everybody's different. And of course, Mary Jackson, when she was at the top of her game, was making more than, say, a junior engineer who might have been white or male. That said, computing was a fairly menial, low-paid job compared to, say, an engineer. And such is the plight of any work that is labeled women's work, even if it was originally, say, male, like secretary, for instance, or ballet dancer. And the pay gap has never really quite ended in any agency, but it certainly would have been more acute back then. But I couldn't give you exact numbers, but you can look at any article on what the pay disparity was and is and translate it to the space industry.
Thank you. We have another question. As an educator, how can you encourage students to find their passion and pursue them?
So if we're specifically, well, I guess we're talking about anybody. So as a teacher, my job is to make things fun. And I hope this presentation is fun. I actually started doing these presentations because I don't have any limits. I can go anywhere and teach something that's my passion. And I have found that the only way you can get people really excited about something is to expose them to it. The reason why there is such a gap between women and male programmers today, right? So this probably surprised you that programming was women's work back in the day, and yet it's not today. Now it's mostly a male field. And that was a very deliberate thing that happened. So when personal computers came out in the late 70s, early 80s, all of the advertisements were aimed at boys. And as a result, boys grew up with personal computers and assumed they were at them, and women were targeted with ads for Barbies. And that does something. So they found that women, young girls and boys would be fairly even in their interests and activities up through about middle school, and then all of a sudden they would diverge very strongly in what they majored in. And women would not be interested in computing and so forth. So I think the most important thing as an educator is to emphasize that these genres of application are accessible and important for everybody. And that's another reason I do a talk like this. I want a woman who's 10. There was a young girl at my first talk that I did that at when I talked about how the Yerkes astronomers paid the women so little, and she said, "That's not fair." And I said, "That's right." She was 6. She's going to grow up knowing that all of these women she saw are her role models. She could be one of these women. So it's so important, and this is why another reason why representation is so important. And Mary Jackson knew this. This is why she stepped down to head the employment department. You've got to have role models to know that this is something for me that I can do.
Amen. Thank you. Cassidy said, "Thank you for your talk. Do you have any thoughts about how to make careers in science more accessible for today's women and girls?" You touched a lot about that. But this is more about the accessibility, I think, than how to get them excited about it.
So again, I think it's all about what you show. I think movies like Hidden Figures, I think presentations like this, I think women in prominent positions, I think a woman running the science talk program at Reuben H. Fleet Space Theater in San Diego, these are all things that show that women are fundamental to everything that we do, and know that there's no exclusion. That said, my wife likes to talk about how she wasn't a feminist until she did the Bechdel-Wallace test on her DVD collection. I don't know if you know what the Bechdel-Wallace test is, but the Bechdel-Wallace test says A movie passes the Bechdel-Wallace test if it has two named characters, women characters, who talk to each other about something other than a man. And she was amazed to find that like 70% of our movies failed that test. So when you are putting together a department or a program or, say, a Galactic Journey website, be conscious of what you're putting together. If you're a magazine publishing literature, solicit and make sure you've got equal representation from everywhere. Otherwise, your unconscious and conscious biases may put you publishing the same people you've always published before and giving the implicit message that anyone else who doesn't fit that, it doesn't belong.
Thank you. And the next question, in what ways does NASA accurately document, celebrate, and credit the history of women in NASA? What % of engineers are women in the present?
I can't give you an exact number. My specialty is much more the 60s than modern NASA. That said, I'll say that NASA does a pretty good job of celebrating its diversity. I remember when Eileen Collins became the space shuttle commander in the 90s, and that was just really cool and a big deal. I think they're pretty good about it now, and I think the proportions are getting, I don't know if they're exactly 50-50, but they're getting pretty good.
Awesome. That's definitely something I like to hear. Somebody would like to know if you're going to be doing more talks in the future because they enjoyed this talk very much. And yes, I hope so.
I'll come back to Reuben H. Fleet whenever you want me. But besides that, I know you have a full slate. I actually do a lot of talks, and especially ever since this plague hit the country and everyone's been stuck indoors, I have done 2 to 3 talks every single week somewhere in the country. And they're all different. I'm an author, so a lot of what I do, speaking of representation, actually, these are the books I've done. Quick plug.
Yeah, please, you should.
Rediscovery, Science Fiction by Women, 1958 to 1963, which is an anthology of some of the best science fiction of the Silver Age. This will be a series, by the way. This is the first 6 years that I'm doing. This book is done really well, by the way. You can probably find it in your local bookstore. And then this is my very first novel. And this is Keetra. This is a space adventure about a bunch of young people who get stuck in hyperspace. I did not expect it to be so thematically appropriate when the pandemic started to be doing this isolation themed book. But it's a hopeful book. Your kids will like it and you will like it. This is Keetra. Anyway, that's this segment brought to you by Journey Press. So what was it? Oh, when am I doing talks? If you go to galacticjourney.org and click on live events, you will see my schedule. And if you've missed any shows, and you've missed a lot at this point, click on taped shows and you can see the shows I've done. And they're divided into bookstore shows, which are mostly author interviews, venue shows, which are like this on a wide variety of topics. You will enjoy all of those. And the Journey Show, which is a show we do every 2 weeks on all sorts of things. The one we did last Saturday was actually on the space race as of 1965. Gemini 4 was in orbit as it happened. Ed White had just done his first spacewalk. 2 weeks before, we did it on the best science fiction of 1964. Before that, it was arts and entertainment of the early 60s. So tons of shows all the time. I would love to see you.
Wonderful. Glad we got that. Everybody got the resource on where to find you, because you've, like you said at the beginning, you've done a talk at the Fleet Science Center before, and it was also very well received. So please go check out his website and see many of his talks to come. Next question is, did the Soviets also have successful women programmers, engineers heading up to and during the space race?
So the answer to that is yes and no. Can you see that?
Yep.
Okay. So the answer is yes and no. They Valentina Tereshkova was a stunt. There were several women in the women's cosmonautic program, but they weren't really cosmonauts. A requirement for them to be cosmonauts was they had to have parachute training. And in fact, one of Valentina Tereshkova's hobbies was parachuting. And the reason why is the very first Soviet space capsules didn't land with their pilots, and they weren't even pilots. They were automatically controlled from the ground. after the parachute went out of the Vostok, they jumped out of their spacecraft and landed in their own parachute because they weren't sure if the spacecraft would land too fast for the cosmonaut to survive. Once Tereshkova went up, they had no other plans for women to be cosmonauts. And in fact, none flew for decades until the 80s. So while it was seen as an embarrassment to America that the Soviets beat us into space, not only with a woman, but also the first civilian, nevertheless, it was mostly lip service. And as far as I understand, I've done a lot of reading on the Soviet Union, not so much on women in the space program, but just women in general as engineers, scientists, artists, musicians, clerical, you name it. Women were second-class citizens in the Soviet Union, make no mistake, despite the lip service communism paid to it. And in some ways, maybe even worse than it was here. Wow.
Thank you for that. We have a question here if we're recording this talk and if it will be available. And yes, we have recorded this, and it is going to be on the Fleet Science Center YouTube channel. If you go to YouTube, type in Fleet Science Center, you'll see our channel, and it's going to be up in the next couple of days. So if you missed the beginning of it or had to log out early, please feel free to check it out once it's online. To the next question. This is a great presentation. Thank you for all this information. The women in the past that were physical computers, how complex was the computing, especially in the space field? What type of education did they need?
Well, as you can see, you didn't necessarily need an advanced degree to be a computer. And in many ways, computers were carrying out the calculations requested of them by the engineers at NASA or NACA. So while a lot of women computers went on to do much more sophisticated things, excuse me, like Katherine Johnson and so forth, the computing didn't necessarily have to be exceptionally complicated. It just depended where you were in the hierarchy. It wasn't as simple as, say, in the 18th century when they first computed logarithm tables and all you had to know was addition and subtraction. That was actually the first case of mass computing ever done. Quite an amazing thing. I wrote an article about it for the Journey. But you did not necessarily need an advanced degree to do the mathematics required. Remember, you were often using machinery too, automatic calculators. So a lot of it was drudge work.
Still probably a little bit too complicated for my math understanding.
Maybe, as like they said, how do you like numbers with Sue Finley? You had to have some aptitude for numbers, but you know, you could be a sophisticated bookkeeper and probably do a lot of what they were asking you to do.
Awesome. And then, have you read the Lady Astronaut books by Mary Robinette Kowal? I hope I pronounced that word right. If so, what did you think? What books about space, fiction or nonfiction, would you recommend?
Okay, so I wish I was more up on current science fiction. The fact is, my dance card is so filled, I have to essentially read everything that comes out 55 years ago and then review it. So I'm very up on fiction back then, of which there's tremendously good stuff that has been forgotten, much like these women pioneers I'm spotlighting. But in terms of Mary Elizabeth Kowal, I have not read her works. I know some people who love it. I know some people who've questioned some of the scientific accuracy of it, but I cannot personally say anything about it. If you're asking books about space that I would recommend, boy, I tell you what, I wish I could do it on here, but I'm on the spot. So if you send me an email, you can contact, if you go to galacticjourney.org and hit contact the traveler, I promise anyone who wants to know what books they should read that are really good, I can tell them. Actually, I will say this, if you go to galacticjourney.org and you go to the search function and you type in galactic stars, those are the stories that we have given the highest ratings to for each year that we've done this. We've done the journey for 6 years now. So if you go to the galactic stars, it's galacticjourney.org/tag/galactic-stars. In fact, I can even type it in if you all could see it. So I'll do that.
Yeah, maybe share it in the chat. That will be great.
So these are like the Hugos, except better because there's more of them. And if anything on that list is going to be great, and anything on that list that has to do with space travel is going to scratch your itch. And let me once again recommend Ketra for all your space travel needs.
I love it. Great plug. The next question is, how many women did NASA hire for the moon landing?
I couldn't tell you a specific number for that. Remember, women were always involved with NASA, and these women that we saw at the dawn of NASA all went to work on the advanced programs. Katherine Johnson did, and Mary Jackson did. All these people kept contributing and bringing other people in. That said, I will say this. I don't know the exact numbers, but women must have been a minority. Talking about how you bring women into it, on the journey, I read Aviation Weekly from back then, and they invariably at the very end have all these ads for engineers. Come work for Hughes, come work for Boeing, come work for Grumman, come work for a whole host of places that just don't even exist anymore. And invariably, they've got pictures of dudes with pipes, standing around a table. Occasionally, you'll have, come to sunny Florida and work at the Cape, and they'll have a man, with his suit over his shoulder, and the woman arranging the flowers behind him. You can bring your wives too. So just from the slant of the advertising, I can tell you that women were never a majority. And in fact, the situation where women were the majority in terms of programming was somewhat unique to NASA, because in the 60s, anywhere else, whether it was in big business or at universities, computers were almost exclusively the province of men, generally in white lab coats and sealing off the shrine of computing from everybody else.
It's good to hear that NASA was on the forefront of that also.
In many ways.
And there is somebody has a suggestion for another talk for you. Could you do a talk that goes further into detail of how the mother of Hubble contributed to the creation of Hubble's space telescope, and how many women have contributed to the space telescopes? So that's a talk idea for you.
Yeah, for sure. I'd love to go through all the observatories over time. That said, I will say that a lot of what I do ends up rooted in the past, because that's my focus. So for instance, I did a talk, which I'd love to do at some point, called Shooting the Moon, which was all about how we went through 10 lunar missions, all of which failed before we succeeded in getting to the moon, and what that meant for America. I am a space historian. That is my bread and butter. So I can do the research and I can do other talks, but it's not the best application for me in some ways.
Thank you. And then, hold on, I'm trying to remember where I was. Somebody would like to politely disagree with you. She's from the Soviet Union, and everyone except of party guys were treated as lower society citizens. Just as a comment, since we have somebody from the Soviet Union on.
I don't know if that's a disagreement.
She said, sorry, I grew up in the Soviet Union and I cannot completely agree with you. Everyone except of party guys were treated as lower society citizens. Right.
No, I think in some ways we're agreeing. Yes. In fact, my great uncle actually was he was a gamma ray astronomer in the Soviet Union. He didn't leave until the curtain fell. And he ended up working. He manages a facility on the Golan Heights in Israel now. His father-in-law was Vitaly Ginzburg, who helped develop the Soviet H-bomb.
Oh, mind-blowing connections. So another question: can you explain about? And I'm going to mess this up.
Paula Chawla and Sunita
Williams. There you go. You can see the questions too. Perfect. I forgot about that.
Well, I know them. The first one, of course, died in the Columbia disaster, 2003, and Sunita Williams was the first person who ran a marathon in space. Actually, she went into the thing and she ran in space for the equivalent of 26 miles, and she's been to space twice. Sunita Williams, in particular, is one of my favorite astronauts, and she's done a lot of outreach. That said, because they are modern, I actually don't know too much about them other than what I've read in the pop science articles.
Got it. There was a question that I haven't gotten to yet. just because I'm not sure if you can answer that, but it's the one about how we can preserve, or how we can get into the habit of archiving our past to preserve our future. You had such great examples of archives that have shown how we neglected spotlighting the women in science.
Right.
Do you have an opinion on that?
Yeah, so it's all about assigning value to them and being, it's kind of like this, to give a controversial example. Every year there are lots of unwanted children who are born, and part of what could make that situation better is if we had more people who were willing to provide homes for them, if we had more state establishments that could take care of unwanted children. If it's a problem we want to deal with, it's a problem we also have to be willing to take responsibility for. So, all right, that was really heavy and probably went too far. But if we want to save the past, we have to be willing to store it. And there's all this stuff. It comes with a footprint, right? If you have this old computer, it's a bunch of wires that slowly corrode unless you have someone who knows how to maintain it. So there's a commitment that needs to be made there to ensure all this stuff gets saved. The more institutions that exist that are dedicated to the preservation and maintenance of these things, the better chance they will survive, because people will know where they can be sent. So for instance, there's the Living Computer Museum in Seattle, which I understand is shut down now because of COVID and may not reopen, which would be an absolute shame because they have a working CDC 6500 computer from 1967 that anyone can get an account on and log in and program like it's 1967. I have personally made the call to my hundreds of people, and I'll make them to you on this lecture. If you have stuff, now I'm looking for very specific things. I'm looking for old technology, specifically computers, stuff like that. If you go to galacticjourney.org and you go to the museum, you'll see there's a place that says museum. I've been slowly putting my artifacts online so everyone can look at them virtually and enjoy them. And eventually I'll have things like, this slide rule and stuff. But this telephone is actually going to be next on the list.
Nice.
So if you've got anything like that, please send me an email. Ultimately, someday, when I'm rich and famous, I want to establish a foundation. I want to hire someone full-time whose job is just to maintain this stuff and make it accessible to the public, either virtually or physically. But yeah, so it starts with a willingness to preserve stuff. When I became a space historian, working at STL, there was a guy who used to be a vice president there, and his son sent me like 6 boxes full of his father's notebooks about missile calculations. I have no idea what I'm going to do with this stuff, but I'm not going to throw it away. And eventually, someday it'll probably get scanned. And in 100 years, someone's going to find this invaluable for research. So
I agree.
Anyway, that was a really long-winded answer that probably went too political anyway.
No, it's perfectly fine. And I think you're right. It just starts with us, right? We need to make sure that if we have something that we don't want to store or can't store, that we'll go out searching for organizations that might be the right place and be willing to store it and preserve it for the future.
And the other thing is, of course, having something like Galactic Journey, whose very mission is to take the past and make it alive to the present, so you can see where we've come from, maybe how far we still need to go, and see the resonances between that time and now.
That's a great thing to add. So we're going to veer away just a little bit from the women in science, because you have encouraged us to do so with a little poster in your back. Somebody would like to ask about time travel. Ask me how.
Yes. So there's really 2 ways to time travel, right? Well, actually there's 3. One is we're all doing it right now, one day at a time. And it's great because the alternative is not very good. The other 2 ways is, one, of course, is there's the go back in time to wherever you want, whether it's to see Abraham Lincoln get shot or to make out with Cleopatra or whatever. And the third is the way I do it, which I have not seen anybody else do, which is a specific period in the past, day by day. So if you go to galacticjourney.org, it is like going through a time portal. It is June 8th, 8th,
8th.
June 8th, 1965, when you go through there. And we go day by day without indicating that we have any knowledge of the future, because it's so important to experience the past in context. And it's very different from this, what I call magpie time travel, where you just go wherever you want, because then you're always looking at it through the lens of the present, and you're not appreciating how those people got there. That's what's so great about Galactic Journey, is it's so immersive and really gives you an understanding for the time that you couldn't get otherwise.
And you have a radio show too, right?
I have the Journey show every 2 weeks. And we do have a radio station that plays all the current hits. Right now, it is playing the music that would be on the air in June 1965. Actually, interestingly enough, I even have a TV station, which unfortunately only I can watch, but about halfway. So this is channel 9 at my house, and it plays the TV that was playing exactly 55 years ago.
Oh my God.
I keep very up to date. I love Burke's Law and Danger Man, and not Bonanza.
I love it. We have one more question that we haven't gotten to yet, and I know it might be a hard one for you to answer, but what percentage of women worked in 1965? That is a little bit more general than even asking about how many women worked at NASA at the time.
So without giving you actual numbers, because I couldn't tell you the exact figures, I can tell you something bigger and pretty important that I just learned. I read an article about it just the other day. There's a certain kind of society that many of us take for granted, that we grew up in as sort of an ideal, the nuclear family idea, that you have your 2 parents and your 2.5 kids and your dog and your house in the suburbs. And this is actually an anomaly. It was not the norm before 1950, when extended families were the norm. And it was not a norm after 1965. There was sort of this 15-year period that was made possible by the affluence of the post-war period. We're speaking, of course, in the Western world right now, particularly in the United States. You had this affluence. You had so much money and cheap education, and that you could have one person do all the work. And so the man went to work, which was interesting, which is kind of a backlash to the 40s, when women were enlisted into the war effort because we needed every available hand. And in fact, the United States was somewhat unique in its deployment of women into the workforce. And then there was the backlash saying, well, women can't work anymore. Men need those jobs back. So for 15 years, men did the work and women did the homemaking. That was the mode, right? And not necessarily the rule. And then after 1965, things started to change. The economy soured a bit. And so you needed to have both parents working. Women discovered that, as Betty Friedan discovered in her The Feminine Mystique, published in 1963, that women were not necessarily fulfilled just staying at home, like Sue Finley, and helping their husbands get degrees. So women went to work for fulfillment, so they had more to life than just being mothers and homemakers, as important as those jobs are. And believe me, I know how important those jobs are. I do the dishes and the cooking in our house. So over the last 55 years since 1965, women have increasingly entered the workforce, and the nuclear family has become more and more untenable. And that's not a bad thing. And we've sort of been trying to figure out, well, what replaces the nuclear family? Anyway, that's a very long-winded way of saying that 1965 is the edge of the era at which women were probably at their least employed vis-a-vis today. And after that, it only goes up to where we see today.
And we still have work to do.
Yeah.
We're not there yet, as we know. Well, thank you so much, Gideon, for this talk. We have answered all the questions, which is great. I think it's the first time we've gotten through all the questions, so I'm super excited. Thank you, everybody, for joining us, for being so engaged, for asking excellent questions. I enjoyed hearing the answers, hopefully just as much as you have, and I learned a thing or two, which is always great. I hope you will consider joining us for any of the other science talks that the Fleet Science Center has to offer. We have our next Sharp Minds Lectures here, event on July 6th, and we're going to have a female scientist joining us, so I'm very excited. She's going to talk about her research on aging, so if anybody's interested in that, and aren't we all? We also have 2 more Science and Science talks on COVID, so if you would like to find out a little bit more on antibodies and where the research is going with that, and what other research is being done in San Diego to help combat that crisis, please join us. You can find all the information on the Fleet Science on the website, which is rhfleet.org, and I'll put that in the chat too, just in case. And then also, please do not forget to visit Galactic Journey. You really can find some amazing stuff there. Check out Gideon's books. I'm all for supporting our wonderful speakers who donate their time and their expertise to these talks. And with that, I would like to, oh, we have 2 comments for you too. Vicky says thank you, and Peter, hi Peter. I know Peter from our live events. Thank you for a very entertaining presentation, and I second that, Gideon. Thank you very much, and thank you everybody for joining us, and have a wonderful evening. We'll hope to see you soon. Bye.